Let us put ourselves in the holy presence of God. Father in heaven, always merciful and giver of life, we humbly ask that you bless each one of us, from the speakers, program committees, guests, and participants. Guide us to make better decisions as we incorporate what we will learn throughout this activity. Thank you for the infinite blessings and countless opportunities. Lord, today as we start our activity, may we always be grateful to learn new things. Shed the light of your wisdom and bless each one, especially our speakers, as they will share their knowledge to us. Through your mercy and grace, may peace and utmost understanding shine and dwell unto us. Almighty God, accompany each one and help us concentrate for us to gain more knowledge as we listen attentively. This we ask in your name. Amen.
Mga kababayan, ang pambansang awit ng Pilipinas.
Bayang magiliw, sa silanganan, alam ng puso, sa dibdib mo'y buhay. Lupang hinirang, tuyad ka ng magiting, sa manlulupin, di ka pasisingin, sa dagat at puno, sa simoy, sa langit mo buka, may nilatang tula at awit sa paglayang pinamahal, ang kisap ng matawag mo'y tagumpay na nagdidinig, ang bituin at araw niya ka ng pamay magdidinig, lupa ng araw na luwalhating pagsikta mo'y langit sa piling mo. Ang iligaya na pagmay mag-api, ang mamatay ng dahil sa'yo. bansang sinisinta. Ang BRS ay sumilang na lingkod ng bayan sa tuwina. Pagtuklas ng bagong karunungan sa iba't ibang turing at ang pagkakabuhay, magkaisa ng dalangin para sa inang bayan.
Ladies and gentlemen, welcome to the National Research Council of the Philippines 4th Annual Basic Research Symposium on Communicating Basic Research, with this year's theme on Herb Talk, the Healing in Green. A pleasant morning to Secretary Fortunato T. de la Peña, to Undersecretary for Research and Development, Dr. Rowena Cristina Guevara, to DOST officials. Warm greetings to the NRCP Governing Board members, headed by the President, Dr. Gregorio E.H. Del Pilar, with the able assistance of Vice President, Dr. Claro Mingala. Good morning to our guests, representing the World Wildlife Fund, the Department of Agriculture, Department of Environment and Natural Resources, Department of Education, the Commission on Higher Education, and the Committees on Public Health and the Environment from the House of Representatives and the Senate. To our distinguished paper presenters, our expert panel of reactors, NRCP members from Luzon, Visayas, and Mindanao, colleagues and fellow researchers, a pleasant morning. I would also like to greet viewers on ResearchPod as we are going live stream on Facebook. This year is full of firsts as we shifted from face-to-face meetings and conferences to online and virtual mode as a necessary response to the COVID pandemic that we are all experiencing. This event today is not an exception. This is the first virtual basic research symposium of the NRCP, and we promise that this will be as engaging as the first three that we had. At this point, let's listen to the welcome message of NRCP President, Dr. Gregorio E.H. Del Pilar. Sir.
Salamat, Secretary Boy de la Peña, Undersecretary Rowena Guevara, mga tagapagsalita at mga reactors, mga kasama sa Governing Board ng NRCP, mga kasapi ng NRCP, mga panauhin, mga kaibigan. Magandang umaga po sa inyong lahat. Noong nakaraang linggo, nagsalita ako sa isang webinar na inorganize ng Philippine Social Science Council at ng kanilang katapat sa India, ang Indian Council for Social Science Research, tungkol sa ginagawa ng mga social scientists dito sa panahon ng pandemya, sa dalawang bansa. Pero ang gusto kong ibahagi sa inyo tungkol dun sa webinar na yon ay yung ibinahagi ng isa sa mga tagapagsalita galing sa India tungkol sa kanilang pagpupunyagi, na isama yung kanilang sinaunang sistema ng pangkalusugan at panggagamot, yung Ayurveda, sa kanilang sistema ng pangkalusugan sa bansa, na namangha ako at natuwa, dahil naririnig natin ang Ayurveda, pero noon ko lang nalaman na ganun pala ang kanilang antas ng pagpupunyagi, na isama ito sa kanilang health system. Nakapaloob ito sa kanilang mga development plans, tungkol sa paghubog ng mga doktor, sa paghubog ng mga residente sa ospital, at sa kanilang health delivery systems, at isinusulong mismo ng kanilang Prime Minister. Itong natural naisip ko, dito sa Pilipinas, ano ba ang medyo kahawig na ginagawa natin dito sa kanilang sistema na ito, sa kanilang pagpupunyaging ito. At naisip ko na bagamat wala tayong Ayurveda, wala tayong iisang sistema no ng tradisyonal na pamamaraan ng paggamot at paniniwala tungkol sa kalusugan, alam nating lahat no na napakayaman ng ating tradisyon no sa paggamit ng mga halamang gamot at mga katutubong pamamaraan ng paggamot. Isa akong pangkaraniwang tao o layman no, tungkol sa bagay na ito. Subalit naiisip ko na napakagandang napakagandang programa ng pananaliksik, no, napaka-straightforward. Narito yung kayamanan ng ating mga tradisyonal na pamamaraan ng paggamot. At nariyan naman ang ating kaalaman sa kanluraning medisina, sa kanluraning agham, no, na maaaring tiyakin, no, i-verify kung alin dito sa mga ginagawa nating pinapractice natin ng mga tradisyonal na pamamaraan at gamot ay epektibo. Malamang ang karamihan sa kanila ay epektibo nga kasi dahil kung hindi, mawawala yan. Ano? Itong mga traditional practices natin na ito, ilang daang taon na ginagamit ito ng ating mga ninuno. Kaya sa proseso ng evolution, kung hindi magiging epektibo ang isang bagay, nawawala din yan. Pero mahalaga na makita natin kung alin dito talaga ang epektibo at makita natin ang batayan, no? Ang batayan ng kanilang bisa. Nang sa gayon ay magamit natin, ma-endorse natin ng malinaw at magamit natin sa iba pang pananaliksik, no? Tungo sa pagsasama-sama o sa pag-unawa natin, alam natin na marami tayong magagawa sa mga kaalamang iyon. Sa India, nalaman ko rin doon sa aming pagtitipon na yon na bagamat mayroong ganitong suporta ang pamahalaan sa bansang iyon, sa Ayurveda, sa pagsasama ng Ayurveda sa kanilang health system, meron ding mga hindi lahat tumatanggap dito. At ganito rin sa Pilipinas, hindi ba? Bagamat alam natin yung naririnig natin na napakayaman nga ng ating traditional practices traditional medical practices, meron ding mga sektor na hindi naniniwala dito. Isa na ako roon noon na dahil nakapag-aral, nagkaroon ng university education, ito yung mga tao, tayo yung mga nagiging hindi masyadong naniniwala sa mga traditional methods of healing and traditional practices, traditional health practices. Pero yun nga, dito sa pagpupunyagi ng ating mga eksperto, ng ating mananaliksik, ito tinatanggap kasi lahat ng tinatanggap very widespread, malawak ang pagtanggap sa makaagham na pamamaraan. Sa pamamagitan nito, makukumbinsi natin yung mga taong hindi naniniwala, medyo skeptical, tulad ko dati, na itong mga traditional healing practices natin ay isang tunay na kayamanan ng ating bansa na dapat nating gamitin para sa kalusugan ng ating mga kababayan. So sa aking mga kapwa pangkaraniwang tao, sa aking mga karaniwang kapwa laymen ngayong umaga, sa ating mga eksperto at mananaliksik, nagpapasalamat akong malaki sa inyong pananaliksik. At sa aking mga kasamang laymen, makinig tayong mabuti. Ako ay handa na ang aking notes para maitala ko ang sasabihin ng ating mga mananaliksik na magbabahagi ng kanilang karunungan tungkol sa yaman ng ating bansa, sa likas na yaman. Magandang umaga po sa lahat.
Thank you, President Del Pilar, for sharing a personal experience and for encouraging all of our attendees to listen attentively and get something out of the presentations that we have this morning. To formally open our 4th Annual Basic Research Symposium, we are pleased to have the Undersecretary for R&D, a regular NRCP member of Division 7, Dr. Rowena Cristina L. Guevara.
DOST Secretary Fortunato T. de la Peña, National Research Council of the Philippines President Gregorio E.H. Del Pilar, NRCP Executive Director Dr. Mayet Sumagaysay, NRCP Governing Board, participants from other government agencies such as the Department of Agriculture, the Department of Environment and Natural Resources, Public Health and Environment committees of both the Senate and Congress, the Department of Education, the Commission on Higher Education, and those from non-government organizations such as World Wildlife Fund. Ladies and gentlemen, magandang umaga po sa inyong lahat. I am pleased to be part of the 4th Basic Research Symposium of DOST's National Research Council of the Philippines, or NRCP. For 4 years now, NRCP has been holding this important symposium on basic research, which we hope will lead to future innovative applications or spawn new research areas based on the project output presentations. For this year, the focus is on new knowledge and innovative discoveries from different pharmacognostic studies, specifically on herbal medicines. Today's theme, Communicating Basic Research Results to the People, Herb Talk, The Healing in the Green, will give us a view of several medicinal plants that are available. In this time of the pandemic that we are facing, being healthy and boosting our immune system are of utmost importance, as well as taking a look at natural medicines that have proven pharmaceutical benefits to help in mitigating the effects of viruses such as COVID-19. We all know now that these viruses exist, and we need to make our own precautionary measures to combat diseases. In the 2nd Basic Research Symposium, NRCP presented the abundance of our Philippine fauna and flora that gave us useful and beneficial learnings on how our country is rich with different resources. As a segue to this, is this herb talk, The Healing in Green, that supports the promotion of low-cost medicine and local plants. The research findings on herbs will be presented, which may be beneficial and useful in promoting a healthy lifestyle of the Filipino people. More than this, the production of low-cost medicine and more new information about some of our medicinal plants that are found everywhere will be presented today. The 4 completed projects to be presented will discuss the effects of different herbal medicines in different health requirements. We have pharmacognostic studies on marang fruit, efficiency of extracts of selected Philippine medicinal plants against the most prevalent and deadly non-communicable diseases, or NCDs, in the Philippines, such as hypertension, diabetes, and dyslipidemia, and how natural oil affects the infusion of medication or healing of transdermal patches. While these are research-based, we look forward to the reactions and inputs of our distinguished reactors who are also experts in their own areas of research, particularly in chemistry. I would also like to mention that we also have our DOST Secretary Fortunato de la Peña today. We thank you for this opportunity to listen to you as we are all in this together, complementing DOST's efforts as it vigorously promotes innovation and directing initiatives towards a vibrant innovation culture in the areas of health, agriculture, pharmaceuticals, and industry. We are also aware that innovation in these areas likewise contribute to the country's socio-economic development. Allow me to personally express my gratitude to our speakers, researchers, reactors, and participants for the support that you are giving not only to the National Research Council of the Philippines, but to the science community as a whole. In closing, I would like to thank the National Research Council of the Philippines for making this event possible. I would also like to extend my sincere appreciation to the researchers all over the country for taking the challenge of implementing science projects in your respective areas in order to provide new knowledge for the betterment of our people. The DOST will always be your ally in research and development. I also understand that we have a well-represented list of participants from the various stakeholders, including the foremost biodiversity advocate organization, the World Wildlife Fund Philippines. It is our hope that research-based information that will be presented will be useful and steer new or even further research, not only for those who have been in research, but also for budding researchers and students. Let us all be part of this significant event and contribute in ensuring the country's development through science, technology, and innovation. Magandang agham po sa inyong lahat.
NRCP has always been inspired with the support of the top officials of the DOST. The inspiration brings many of our researchers to greater heights in research and scientific productivity and innovation. Colleagues, let's give a hand to DOST Secretary, a former NRCP President, and a regular member of Division 7, Secretary Fortunato T. de la Peña. Sir?
Magandang umaga sa inyong lahat. It always gives me great pleasure to be with young and promising researchers with the thought that they will soon be able to contribute to the science community through their own research activities. I was told that the participants in this event are coming from different educational institutions all over the country. So we have representatives from UP Manila, Los Baños, UP Diliman, Ateneo de Manila University, Emilio Aguinaldo College, Far Eastern University, St. Paul University, Manila, Piati, Pamantasan ng Lungsod ng Maynila, University of Santo Tomas, University of the East, De La Salle University, Manila Central University, St. Michael's College of Laguna, Fatima University, Perpetual Health System Laguna, and we have some coming from high schools. Maybe they read it through the NRCP Facebook page. So we have participants coming from San Roque National High School in Nueva Ecija, and also from Northern Bukidnon Community College. So it is really interesting and exciting to have all of them together here. I personally would like to mention that the research symposium that we are having now is already the fourth since they started having this basic research symposium. And the theme that has been adopted for this one is Herb Talk, the Healing in Green. And actually, we take this as an indication of your interest not only in the results of projects but also in planning for your own research activities. The year before, I think the topic was also very interesting. It was dealing with water and energy, and this time we are focusing on herb that can be used for pharmaceuticals. It has been 7 or 8 months now since we have been under this pandemic, and of course all countries are finding solutions. They are fighting COVID-19, and in the case of the Philippines, we have really contributed in many aspects. It's not only on the health side but also on the livelihood side, on the idea of putting order to things during this situation, and of course thinking about the future. There are remarkable contributions. Actually, mostly are members also of the National Research Council of the Philippines. For example, Dr. Raul Destura, who is a Vice President of NRCP, and who has contributed by way of his PCR-based diagnostic kit for COVID-19. We have also been doing clinical trials on many therapeutics that are plant-based or plant-derived, and we are repurposing some of these therapeutics that have been used already for other diseases to be tried for COVID-19. And I think it is also important to note that NRCP has ventured into the social dimensions of this pandemic. So we had, if I recall already, 5 research dissemination sessions covering various aspects of the pandemic, from the feelings and behaviors of people to the kind of policies that have been issued, and of course even on the mapping of mental health and the possible interventions that we can have. Now, so as I said, every year we have this basic research symposium, and it is not only listening to the presentations, but also reflecting on how and what you can contribute, okay, to the needs for solutions in our country. It's not only the pandemic. There are many problems that we are facing, and there are many opportunities also that we can take advantage of. And maybe this basic research symposium can give you an idea as to how, for example, a proposal can be prepared better, so that you can have better chances at funding. Now, NRCP is making use of the outputs of research and translating them into various forms that may be used by different sectors. For example, it can be translated into policy briefs that can be used by our policy makers and the decision makers. And of course, it can be written in a popular manner so that it can be known and understood by our common people. Now, at this point, I would like to personally thank the researchers who are making their presentations today, and I would like to give special mention to the following: to Dr. Joseph Marie Carequincia, who is from the San Pedro College in Davao, for his studies on the medicinal properties of the marang fruit. And then we have Dr. Erna Arrollado from De La Salle Institute of Health Sciences in Dasmariñas, Cavite, for her evaluation of Philippine plants. We also have Dr. Brian Paul Bulatao for his transdermal. Dr. Arrollado is from the UP Manila Pharmaceutical Research Institute, and also Dr. Brian Paul Bulatao for his transdermal patches. And for the topic on herb-drug interactions in the use of top medicinal plants in the Philippines, that is it was done by Dr. Alicia Katabay, who is the one from DLSU Dasmariñas. So these are indeed very exciting researches, and it is my hope that after this symposium, other researchers may pick up and undertake further studies. Now, I was mentioning about the importance of writing good proposals, and so I think that would be the first step, that those of you who have not yet, shall we say, been able to do a research project funded by an agency, you really have to start with proposal writing and submit it for possible funding. Now, as far as the preparations are concerned, I really would like to thank the National Research Council of the Philippines, led by our President, Dr. Gregorio del Pilar, and of course our Executive Director, Dr. Marieta Sumagaysay, and the whole NRCP team for coming up with this basic research symposium. And I really would like to express my, shall we say, satisfaction at these developments. I was once an NRCP president, actually for 5 years, and I have seen the progress that has been made since that time. I was there from 2002 to 2007 until today, when we can see that there has been an increased level of activities and also an expansion of the scope of researches that are being done through NRCP. So maraming salamat sa inyong lahat at magkaroon tayo sana ng isang very productive symposium. Thank you.
Thank you. Salamat po, Secretary De La Peña, for that inspiration and for always giving NRCP events more meaning as we strive to utilize basic research results in various ways that ultimately leads to better quality lives of Filipinos. At this point, we break for a short photo opportunity. We'll have the paper presenters, followed by the presenters and the reactors, and then NRCP officials, and then we'll have a fourth photo of all of the speakers and the reactors. So can we have the first one, please? And can we request the paper presenters to turn on your cameras for the photo opportunity? Thank you. Can we have the reactors with our presenters, please? Please turn on your cameras. Officials, more around, please turn on your cameras. Okay. So I'll move on. Thank you very much for obliging on the photo opportunity. Okay, so after hearing the three messages, we are now ready to listen to our four paper presenters. However, before we do that, let me tell you a quick background of the NRCP Basic Research Symposium. Based on its mandate as provided in Act 4120, which created it, the Council shall promote basic and fundamental research. We don't stop with the conduct of the basic researches. We bring the results further in various platforms, such as what we are having now. We believe that various stakeholders can pick up the results for a range of purposes: the academe, the industry, and the policymakers. And this was mentioned by Secretary De La Peña earlier. In 2017, NRCP brought you the results of 7 NRCP-funded researches which talked about the challenges in education. We had papers ranging from the pedagogy of financially disadvantaged students to cultural metaphors of poverty to the role of the university in enterprise development and innovation to the manning productivity gain cycle and emerging industries. We also had the quality of life in the age of ICT, the uses and users of ICT and the impact on health and education, and we also had validation of word lists for top 7 Philippine languages used in K-3 curriculum. In 2018, we had the value of Philippine flora and fauna and we had 6 papers presented. And this talk on the medical potentials of marine flora, the Pinoy herb extracts for achy gout, the genetics of our very own herbs, about the corny worm, the kohol, and how they grow and multiply, and some native and introduced rats in Mount Banahaw. Last year, 2019, the theme for our BRS was Lifelines and Microbes, where we presented another 6 papers. For the microbes part, we had the Fungal Avengers, the Infinity War against deadly microbes. We had the microbial treasures in Philippine mangroves, and some bad bacteria. For the lifelines, particularly safe potable water and green technology, papers were on electrochemical sensor for heavy metal detection in water, green technology using fuzzy mathematical programming approach, and the next generation all-solid-state ion battery energy storage. This year, we go herbal, and our 4 paper presenters will share with us results of various pharmacognostic studies done on Philippine medicinal plants. So after the 4 presentations, we will listen to 2 reactors, whom I will introduce later, and then we will have the Q&A. Please encode and type your questions in the chat box, and I will read as many of them as time will permit us. But for an unanswered questions, the NRCP Secretariat will collate those questions for our speakers to respond. Then we will send you the responses at a later date. So we're now on the meat of our activity today. We go to our first paper presenter. He belongs to the NRCP Division of Pharmaceutical Sciences. He is a faculty of the San Pedro College in Davao City, and he will share with us his results on the pharmacognostic studies on the fruit Artocarpus odoratissimos blanco moraceae, and this is the marang fruit. Let's welcome Dr. Joseph Marie Quiricensya. Dr. Quiricensya, please.
A sought-after pasalubong from Davao can also be an efficacious medicinal plant. I would like to talk about one of my recent scientific productivities, which was supported by the National Research Council of the Philippines. It is all about standardizing and establishing the safety and efficacy of marang, botanically known as Artocarpus odoratissimos. Up to this time, our society is in quest for finding alternate or supporting commodities that is used to treat or manage diseases or ill conditions which are common to the Filipinos, such as hypertension and diabetes mellitus. One of these commodities would come from medicinal plants. This medicinal plants bears active phytochemical compounds. A number of plants which belong to the group or genus of Artocarpus have long been studied as medicinal plants which bears polyphenolic compounds. Since there are limited scientific investigations about Artocarpus odoratissimos, this scientific work was aimed to assess the pharmacognostic characteristics of the fruit of the plant, by which its safety and purity as a medicinal plant was ascertained. Characterization of polyphenols, acute oral toxicity profiling, and in vitro and in vivo hypoglycemic properties of the plant were also established. The workflow of this study involves different processes that started from plant sample collection, pharmacognostic properties determination, up to the conduct of the biological assays. For the evaluation of the pharmacognostic properties of the fruit sample, Results of this study showed that the sample contains minimal ash and moisture contents based on the standards of limits set by the USP/NF. Ash content represents impurities of a plant material, such as carbonates or silicates. Moisture content must be also minimal because higher amounts of it can attract contaminants in the plant material. The extractive values testing is employed to determine the type of solvent that would be used for processing the main plant extract, whether it would be an aqueous solvent or an alcohol-based solvent. The alcohol solvent got the highest extractive value and was selected for plant extraction process. The microscopic analysis of the fruit sample of marang utilized methylene blue and safranin as its dyes. It consists thin-walled cells densely packed with granules, and some of these granules occur in well-defined clusters. In the fluorescence analysis, the dried pulp powder of the plant exhibited different colors when treated with various chemical reagents. This pertains to the presence of phytochemical compounds. The fruit pulp was subjected to lyophilization process in order to remove the water content of the plant before it undergone the main extraction process using an alcohol-based solvent. The crude or main extract has an ample yield and was subjected to solvent fractionation using a partitioning scheme with a nonpolar, semipolar, and a polar organic solvent to form different solvent fractions or semi-crude extracts. All of the extract samples that were obtained were subjected to the screening of the presence of phytochemical compounds such as polyphenols using chromatographic and spectrophotometric with the aid of visualizing and complexing reagents respectively. Among all of the samples, the semi-polar and the polar solvent fraction showed significant qualitative and quantitative amounts of polyphenolic compounds. In the in vitro hypoglycemic activity determination, alpha-glucosidase enzyme inhibition model was utilized because this enzyme, alpha-glucosidase, is one of the novel targets for blood glucose lowering activity. Inhibitors of this enzyme is needed to control the enzymatic activity and decrease this negative physiological phenomenon. Amid all of the semi-crude extract samples, the semi-polar fraction exhibited considerable enzyme inhibitory activity with an IC50 value of 26.42 micrograms per ml, which is similar to the result of acarbose, the positive control and an established alpha-glucosidase inhibitory agent. IC50 values were computed using four logistic parameter regression analysis based from the percent inhibitions of the respective concentrations of the extract samples. The extract sample who exhibited in vitro alpha-glucosidase inhibitory activity was selected to be utilized for further testings for acute oral toxicity test and in vivo hypoglycemic assay using rodent animal models. Animal research permit from the Bureau of Animal Industry was secured prior to the conduct of the biological assays. Acute oral toxicity testing followed the guidelines from the Organization for Economic and Cooperation Development, specifically the main 425 test, and it was found out that the extract sample was safe up to 2,000 milligrams per kilogram, the upper limit for the test animals. There were no variations in the normal behavioral patterns of the test animals up to 14 days of observation. Gross necropsy procedures were performed by a licensed veterinarian in which interpretations were normal and there were no changes in size and consistency of the essential organs of the test animals. Microscopic analysis of the liver and kidney organs were conducted by a veterinarian histopathologist. Results show that there were no signs of proliferation and congestion of blood vessels. Therefore, the extract sample is fairly non-toxic up to 2,000 milligrams per kilogram body weight dose of test animals. This was the basis for the dosing, the low, medium, and high doses of the extract sample applied in the in vivo hypoglycemic assay. The measurement of blood serum levels of glucose of test animals were conducted following baseline extraction, post-induction of hyperglycemia, and post-extract sample treatment monitoring for 7, 14, and 21 days of the biological assay. The weights of the animals were also recorded, and there were some notable changes that happened following the induction of hyperglycemia to the test animals. Results showed after administration of the extract sample for 21 days, it had a comparable activity with the positive control acarbose, dose at 10 milligrams per kilogram body weight of test animals in decreasing serum blood glucose levels. In conclusion, Artocarpus odoratissimus fruit sample passed the limits of specifications for pharmacognostic analysis. This pertains to the preliminary establishment of this plant species as a medicinal plant. It possesses polyphenolic compounds which might be responsible for its substantial in vitro alpha-glucosidase inhibitory activity and in vivo hypoglycemic activity. It is safe and it is fairly non-toxic up to 2,000 milligrams per kilogram body weight dose of test animals. For future directions, it would be that the other plant parts of this plant species be considered for analysis, and in-depth screening of other types or kinds of active phytochemical constituents on this plant species would be considered also for testing. One of the scientific significance of this research work would be a source of information about its medicinal value for those people who are involved in cultivating and propagating this native plant species, especially here in Mindanao, in which the fruit of this plant is not just a local delicacy, but it is a safe and efficacious medicinal plant material. In behalf of my collaborators and co-authors, Ms. Kay Anjonatas and Dr. Ross Vasquez, I am Joseph Marie Queriquinsha from San Pedro College, Davao City, and an associate member of the Pharmaceutical Sciences Division of the National Research Council of the Philippines. Once again, good day and daghang salamat kaninyong tanan.
Daghang salamat. Thank you, Dr. Queriquinsha, one of our young researchers at NRCP. So for laymen like us, we understand that marang is a safe and efficacious non-toxic source of medicinal plant. Dr. Queriquinsha won first place in the professional category for research poster exhibit competition last year. And this is the first international research conference on healthcare sciences with the theme Transforming Research Towards Collaborative Healthcare Outcomes. And this was it was called Liang 2019, held last November 19 to 21, 2019. Again, daghang salamat. Okay, our second speaker is currently a governing board member of the NRCP and is chair of the Division of Pharmaceutical Sciences. She is a professor from UP Manila. Her specializations are on natural products and pharmacology. A little thing about Dr. Arellado, who is our next speaker. She has a total of 20 published scientific papers that garnered 72 citations. Her H index is 5 and I-10 index. She is currently the director of the Institute of Pharmaceutical Sciences of the University of the Philippines, Manila. Dr. Arellado is an achievement awardee of the NRCP in 2016. She will talk today on the extraction and bioassay evaluation of selected Philippine plants for diabetes, hypertension, and dyslipidemia. Ladies and gentlemen, Dr. Arellado.
Non-communicable diseases, also known as chronic diseases, are diseases that tend to be of long duration, which are the results of a combination of genetic or family history, physiological, environmental such as pollution, and behavior factors such as tobacco use, excess sodium intake, alcohol use, and insufficient physical activity. Because NCDs are generally attributable to the aforementioned behaviors, they are often referred as lifestyle diseases. These diseases cannot be spread from person to person, or simply known as non-contagious diseases. The NCDs impede poverty reduction because of their lengthy and expensive treatment. They are palpably felt by the disadvantaged people who tend to get sicker because of limited access to health services. They are even recognized as major global challenge in attaining sustainable development. The main types of NCDs are cardiovascular diseases, which include hypertension and dyslipidemia, diabetes, chronic respiratory diseases, and cancer. This study will only focus on hypertension, dyslipidemia, and diabetes. Hypertension is a condition wherein the blood vessels have persistently raised pressure. Approximately 1.13 billion people have hypertension, wherein less than 1 in 5 people have the problem under control. Dyslipidemia is defined as an abnormal level of cholesterol and other lipids in the blood circulation. This is an important risk factor not only for the coronary heart diseases, but also for cerebrovascular diseases. Lastly, diabetes is a chronic metabolic disease characterized by high levels of blood glucose leading to complications in the heart, blood vessels, eyes, kidneys, and nerves. Around 422 million people are affected by this disease. Kayo, sino ba sa inyong may diabetes dyan? Baka marami ng iba niyan, may naputulan ng paa, o baka hindi na makakakita dahil sa diabetes. Annually, about 41 million people die because of NCDs. This figure shows the top 10 global cause of deaths in the year 2016, wherein NCDs are included. This indicates that NCD is a major burden in the health of people that needs to be addressed. The top cause of death globally is ischemic heart disease, which is about 9 million cases. This disease is caused by the narrowing of arteries, which can be attributed to cholesterol. In addition to high cholesterol levels, hypertension is a major risk factor for stroke, which is the second leading cause of death in 2016 and accounts to about 6 million deaths. Seventh on the list is diabetes with about 2 million deaths. Looking at the Philippine setting, all 4 Ncds are also included in the top leading cause of death in the country. The figure shown indicates that Ncds put a great burden in the health system in the world. For our study, we focused on 2 main Ncds, namely cardiovascular diseases, hypertension, dyslipidemia, and diabetes. Ncds are addressed using synthetic drugs but are costly and have pronounced side effects. In view of this, bioprospecting compounds are advocated because they are believed to be better tolerated by the body than their synthetic counterparts. Bioprospecting is defined as a systematic search for products derived from bioresources such as plants that can be developed further into drugs for the benefit of the society. Plants have been used since antiquity for the treatment and management of various diseases worldwide because of the action of phytochemicals present. These plants may contain active compounds capable of managing or treating certain diseases. In this study, we utilized 10 plants using leaves and flowers. For the leaves, these are Rhaphidophora merillii, Artocarpus blancoi, Platycladus orientalis, Sargassum crassifolium, Kalanchoe pinnata, Syzygium polycephalum, Adonidia merillii, and Canarium luzonicum. While for the flowers, these are Rhizophora mucronata and Acalypha hispida. Some of these plants might be familiar to you. Some of them are common to you in their common name, like for example, amlong, antipolo, bakawan. Plants were prepared for extraction by maceration for 3 days using different solvents such as N-hexane, ethyl acetate, methanol water combination, and water. The extracts were subjected to in vitro enzyme assays which are involved in the disease process. For diabetes, we used alpha-glucosidase, alpha-amylase, and dipeptidyl peptidase 4 enzymes. For dyslipidemia, we employ beta-hydroxy, beta-methyl-glutaryl coenzyme A reductase, and for hypertension, renin. After the enzyme assays, the IC50 or the percent inhibitions were computed and were analyzed statistically. For alpha-amylase, A. blancoi hexane extract exhibited the lowest IC50 at 1.4 times 10 to the negative 3, signifying its strong inhibitory activity against the alpha-amylase enzyme. It is also worth noting that its IC50 value is 3 times lower than of the positive control acarbose, indicating that it is more potent. For alpha-glucosidase, our mucronata aqueous extract had IC50 of 10.022 microgram per ml. Both data showed no statistical significant difference with the positive control acarbose. The enzymes A amylase and A glucosidase are involved in the breaking of complex carbohydrates into smaller chains of glucose. This process increases the amount of glucose absorbed into the circulation, which may lead to diabetes. Inhibiting these enzymes decrease the available glucose in the system and help manage diabetes. For DPP4 enzyme assay, our mucronata aqueous extract exhibited the highest percent inhibition at 300 microgram per ml, which is 48.455%. This is close to the activity of positive control sitagliptin, which is at 52.342%. Inhibiting the enzymes DPP4 will result in an increased level of incretin, causing the inhibition of glucagon, elevating insulin secretion, and decreasing blood glucose levels. Inhibition of HMG-CoA reductase can be observed at various concentrations of different extracts. This table shows the activities of the hexane extracts against HMG-CoA. This table shows the activities of several ethyl acetate extracts against HMG-CoA. The highest inhibition of HMG-CoA reductase was observed in Emeryl E methanol water extract at 500 microgram per ml, an inhibition of 47.627%. HMG-CoA reductase is the rate-limiting enzyme for the cholesterol biosynthesis. Thus, inhibiting it will decrease the level of cholesterol produced. Inhibition of HMG-CoA reductase can be observed at various concentrations on the different extracts. This table shows the activities of the hexane extracts against renin. This table shows the activities of several ethyl acetate extracts against renin. Identified plant extracts were found to inhibit renin, such as methanol water extracts of A. blancoi, P. orientalis, and K. pinnata. Renin is part of RAAS, or renin-angiotensin-aldosterone system, which is a hormone system that regulates the blood pressure and fluid balance. Renin is an enzyme secreted by the kidney and is also present in the placenta. That is part of a physiological system that regulates blood pressure. Inhibiting renin is a way in managing hypertension. The bioactivity of the extracts can be attributed to the phytochemicals such as flavonoids, alkaloids, glycosides, saponins, and anthracinones. The actions of these phytochemicals may act competitively or non-competitively on the enzymes. In conclusion, the study identified viable plant sources of lead compounds for future drug development studies against lifestyle diseases. Artocarpus blancoi hexane extract and Rhizophora mucronata water extract are viable sources of lead compounds targeting enzymes linked to diabetes. Adonidia merillii methanol water extracts may possess lead compounds that act on the enzyme linked to dyslipidemia, while the methanol water extracts of Artocarpus blancoi, Platycladus orientalis, and Kalanchoe pinnata may have compounds capable of inhibiting the enzyme linked to hypertension. As pointers for discussion and recommendations, bioassay-guided isolation and purification can be done to determine the identity of the compounds present. Combining plant extracts can also be studied for possible synergistic activities. Conducting in vivo experiments will also strengthen the claims of the previous in vitro enzyme inhibition tests on each disease state. With the data that can be generated in these future researches, formulation studies may then be initiated. I would like to end this presentation by sharing to you this quotation. For every disease, God has a plant for it. Maraming salamat po.
Thank you, Dr. Arellano. For every disease, God has a plan for it. So remember that. Yes, the participants, I would believe, will agree with you that many of the plants in your study are actually very common and maybe are in their backyard. Thank you. For our third paper presenter, we have an expert from the Division of Pharmaceutical Sciences. Her specializations are on drug analysis and quality control and on separation sciences. She is currently a professor and dean of the La Salle Health Sciences Institute, Dasmariñas, Cavite. An NRCP Achievement Awardee in 2015, she has 12 published scientific articles that garnered a total of 120 citations. Today, she will share with us the results of her study on determination of herb-drug interactions in the use of top medicinal plants in the Philippines. We are pleased to have Dr. Alicia P. Katabay. Ma'am?
So our study is in the determination of herb-drug interaction in the use of top medicinal plants in the Philippines. I am Dr. Alice Katabay, and I will be discussing this as part of our celebration. So if you will look at the screen, what do you see? Okay, so these are actually the top 10 medicinal plants in the Philippines. And this has been researched quite a lot. No? About 70% of the world population actually use or currently use herbal medicine. And they do so because they think that they are actually safe. But are we sure that it is actually safe? So herbal medicines and botanical products in dietary supplements have been demonstrated to carry same dangers, no, as that of the pharmacologically active compounds found in modern medicines. So these are the countries in Asia that actually use herbal medicine. And if you will look at the percentages, you will see that they use it quite a lot in their medical practices. No? So these herbal drugs are actually used as complementary medicine. Some doctors actually prescribe the use of this herbal drug instead of. And in some cases, these herbal drugs are used as part of integrative medicine. Up to 72.8% of people with diabetes actually use mostly herbal medicines and dietary supplements. So if you will look at the graph, you will see that in addition to other common practices, the use of herbal drug has been entrenched in some of these countries. Nearly 25% of American adults use dietary supplements, and they do so with prescription medication. Like if you have diabetes in the Philippines, you are encouraged to take charancha or sige, mag-ampalaya ka kasi it will help your diabetes. So what will be the danger for this? No? Are we sure that there will be no drug interaction? Are you using any of these drugs? It is estimated that 1 out of 2 patients with a chronic disease will consume an herbal medicine to improve their health, their welfare, even without consulting a physician or a pharmacist. We consult our neighbor, we consult our friends, and we just want to emphasize that natural is not always safe, as we will point out later on as we look at the study that we have done on this. So what is Cytochrome P450 and drug metabolism? So they are enzymes that actually facilitate the metabolism of your drug to its constituent metabolic product so that you can eliminate it. Once your drug has given you the expected pharmacologic effect, you expect it to get out of your system, right? So if you will look at all the CYP, so in the slide, you can see that there are various CYP enzymes that are actually utilized for drug metabolism. And we will be looking at 3 of these. So you have CYP1A2, CYP2D6, and CYP3A4. So we chose these 3 enzymes because these are the enzymes responsible for the metabolism of most drugs that we buy for our simple ailments and for our chronic diseases. Okay? So this is our standard metabolic reactions. Okay? So for CYP1A2, the reaction is with 7-MR. O-demethylation will happen to form the resorufin. So what is resorufin? This reaction actually shows you that the CYP enzyme metabolizes 7-MR, and the metabolic product is a product that actually fluoresces. So meaning you can measure or you can quantify the amount of fluorescence. The same way for CYP2D6 and CYP3A4, they have specific substrates that actually forms fluorescence samples or fluorescent metabolites. And these are the ones being measured. So what will be the role of herbal drugs in this case? The herbal drug actually will show that they can or cannot interfere with this reaction. So in layman's term, what will happen is like this. So if you have a product added to your reaction, for example, the CYP1A2, you added your herbal product. If this herbal product is an inhibitor, the reaction will not happen. So if the reaction will not happen, you don't have the fluorescence. And the decrease in fluorescence actually shows that your product or your herbal medicine is actually interacting with the reaction. The study involved the preliminary investigation on the inhibition of CYP1A2, CYP2D6, and CYP3A4 enzymes. What we use are human liver microsomes expressing drug metabolizing enzymes, including cytochrome P450. The enzyme inhibition of the CYP450 isoforms was determined using a spectrophlorometric technique that involved enzyme-specific substrates. Again, to review, you have your 7-MR, we have the BFC, and we have the BQ to study the inhibition of these three chosen cytochrome enzymes. The substrate at half saturating concentration, which we determined previously, were incubated at 37 degrees centigrade with your pooled human liver microsomes. Phosphate reaction buffer was added, as well as nicotinamide adenine dinucleotide phosphate, so that you have the complete reaction. So the mixture was centrifuged to separate the microsomal protein, determined using our fluorostar. So this actually determines the emission and excitation wavelengths. Extracts showing more than 50 inhibition at top saturating substrate concentrations were considered as having an inhibitory effect on the enzyme. Okay, so we did optimization of the procedure, and the optimization include extract concentration, substrate concentration, the order of addition of extract and substrate, the inclusion of pre-incubation, and the duration of incubation. So this is the CYP1A2 inhibition profile of all the 10 medicinal herbal drugs. Okay, so if you will look at this structure, you will see some of the herbal drugs enclosed in those dotted lines. So you have there your Tsaanggubat, Nyugnyugan, Sambong, and Acapulco. These are actually the compounds that exhibited the high percentage inhibition value. If you will look at Nyugnyugan, at half concentration, you already see inhibition. So if you will look at the next slide, okay, that's CYP2D6 inhibition, you will see that the inhibition that are shown by your herbal drugs are not that significant. The inhibition is so minor that it will not affect the production of fluorescence. However, in CYP3A4, if you will look at bawang, it's only bawang that actually exhibited inhibition, high percentage of inhibition. As a conclusion, we have seen that Tsaanggubat, Nyugnyugan, and Sambong may have the ability to inhibit CYP1A2 in a dose-dependent manner. Acapulco only exhibits enzyme inhibitory effect at 10 to 50 micrograms per ml concentration. Lagundi and Ulasimang Bato have moderate CYP1A2 inhibition. Bawang may have an inhibitory effect against CYP3A4. And due to the possibility of CYP inhibitory action of herbal medicines, their concomitant use with certain drugs should be considered with caution. So what do we mean exactly when we say that herbal drugs inhibit these enzymes? When you take your drug and it has exerted its pharmacologic effect, the next thing that will happen is that this will be metabolized so you can actually excrete it. However, if you have enzyme inhibition, the enzyme of metabolism will not work because it will be inhibited. It cannot metabolize your pharmacologically active compound to its metabolite so that you can excrete it. So what will happen, therefore, is that you will have a prolonged effect of your drug, or you will have toxicity because it might increase the level of the drug in your system. So that's it for today, and I hope you stay tuned for another session like this by NRCP. Thank you again for listening.
Thank you, Dr. Katabay. So, to all our participants today, a little caution when we take this medicine, the supplemental medicine. So, thank you, and we will be back with you during the Q&A. Thank you, ma'am. Our fourth presenter today belongs to NRCP Division of Pharmaceutical Sciences. He is Assistant Professor of the College of Pharmacy, UP Manila, and is currently on study leave and finishing his doctoral degree in Thailand. He will talk on evaluation of matrix-type fluvastatin transdermal patches and the effects of natural oil in permeation. Ladies and gentlemen, let's welcome Professor Brian Paul Bulatao.
Hi everyone and welcome. I'm Brian Paul Bulatao and I'm so pleased to share with you some preliminary data of our study entitled Evaluation of Different Polymers and Natural Oils as Excipients of Simvastatin Matrix-Type Transdermal Patch. In 2017, it has been identified that the leading cause of death among Filipinos is ischemic heart disease. The World Health Organization reported that 1/3 of ischemic heart disease was attributed to hypercholesterolemia. In 2008, a survey conducted by the Food and Nutrition Research Institute showed that among 7,700 Filipinos, 21.2% had borderline high cholesterol levels, while 10.2% had high cholesterol levels. Due to the increased prevalence of hypercholesterolemia, many anti-lipidemic drugs have been formulated and sold in the market. However, they have very low absorption due to first-pass metabolism, thus requiring frequent administration to obtain the desired therapeutic effect. They also have undesirable side effects that are gastrointestinal related. Transdermal drug delivery system offers an alternative solution to solve these problems. In this system, the drug is dissolved in an inert polymer matrix or reservoir. Application of the transdermal patch to the skin produces a concentration gradient passing through the skin, moving further down the skin layers and into the bloodstream at a controlled constant rate to the specific site of action. Therefore, we aim to optimize a simvastatin transdermal patch by utilizing natural oils as permeation enhancers and natural polymers from plant seeds as drug reservoir. Plant seeds were explored as sources of excipients in simvastatin transdermal matrix patch to reduce the environmental problems caused by these plant wastes. We also use synthetic polymers to compare with the transdermal patch produced using natural polymers. Starch, which was obtained from the seeds of mango and jackfruit, was used as the natural polymer. The natural oils used were extracted from the leaves of oregano, lemongrass, and coconut germ. The physicochemical properties of the natural oils were then characterized. Firstly, we tested simvastatin, the active ingredient in this study, for its potency through high-performance liquid chromatography as the method of analysis. Simvastatin was then combined with excipients that have different functions in the formulation. Although excipients are known to be inert pharmacologically, they can undergo physical or chemical interactions with drug substances under favorable environmental conditions. Therefore, compatibility studies have been performed to evaluate the interactions among simvastatin and the excipients, as well as the interactions among the excipients themselves that were used in the study. The influence of varying the temperature was also explored. Changes in color and physical appearance were observed at baseline and after 4 weeks. For the optimization of transdermal patch formulation, solvent evaporation technique was used to prepare the transdermal patches using aluminum foil as the backing membrane. The use of polymer solution as drug reservoir, consisting of the polymer, ethanol, and glycerin, was established in order to obtain a homogeneous solution or mixture. Ethanol served as the solvent and glycerin served as a plasticizer. Simvastatin and butylated hydroxytoluene were incorporated and mixed until homogeneous. Butylated hydroxytoluene served as the antioxidant. Finally, the mixture was poured into the backing membrane. The prepared patches were then evaluated through their organoleptic properties. Here, you see the images of extracted starch and natural oils from the plant sources. The starch from mango seeds had a higher yield compared to the starch extracted from jackfruit seeds. The extracted starch exhibited comparable organoleptic properties with official starch in USP, which were white to off-white in color, odorless, and fine in texture. The coconut germ oil yielded a clear colorless oil, while the lemongrass and oregano leaves yielded a clear light yellow oil. The physicochemical properties of the oregano, lemongrass, and coconut germ essential oils were obtained to determine the quality of essential oils extracted from plants, which may affect the properties of the formulation. The results for the specific gravity, a refractive index, and the solubility tests are shown on the table. Based on the solubility test results, ethanol was chosen to be incorporated as solvent for the solvent evaporation technique as a method to prepare the transdermal patches. Physical observations and TLC profiling were done after the natural oils were subjected to exposure at 40 degrees Celsius and at room temperature for 2 hours. The lemongrass oil was not stable at 40 degrees Celsius since it hardened and showed no spots at TLC profiling. For the coconut germ oil, there were no differences observed on the organoleptic properties and TLC profiles when exposed at both temperatures. The drug potency of simvastatin was shown to be 100.4%, which conformed to pharmacopoeial specifications of not less than 98% and not more than 102%. For the drug, excipient, and excipient compatibility testing, there were no incompatibilities between simvastatin and the excipients as no changes were observed upon visual observation. For the polymers, the compatibility results were aided with thermogravimetric analysis. Based on this figure, the transdermal patch preparation with hydroxypropyl cellulose as polymer showed the best result in terms of pharmaceutical elegance. The patches containing the starch from natural sources resulted in cracking, while polyvinyl alcohol and polyvinyl chloride created bubbles after drying. So the results were due to the insolubility of starch, polyvinyl alcohol, and polyvinyl chloride in ethanol. The patch prepared with hydroxypropyl cellulose displayed an opaque and white homogeneous matrix on its backing membrane. So the choice of hydroxypropyl cellulose as drug reservoirs, supported by previous studies using hydroxypropyl cellulose as a polymer, such as in furosemide transdermal formulation. So in this study, we were able to evaluate various polymers and natural oils from plant sources as possible excipients to optimize a transdermal matrix patch of simvastatin. We were also able to identify the excipients that are compatible with simvastatin for the formulation. The characterization and compatibility studies show that the use of hydroxypropyl cellulose as polymer provides the best formulation to prepare the simvastatin transdermal patch. And this research provides preliminary data for future studies and improvement of a simvastatin transdermal patch formulation. And finally, this technology can be used by the local pharmaceutical industry as a simple alternative utilizing plant-based excipients. Thank you very much for listening.
Thank you, Dr. Bulatao. Yes, we take note of how the research results can be utilized, especially by our local pharmaceutical industry. Salamat po. I believe that we have a lot of questions now, and you may start writing them in the chat box. I will read them after we listen to our expert reactors, whom we sincerely thank for their time and the support they are giving to our researchers in particular and the Council in general. I am honored to introduce our first reactor, a member of NRCP Division of Chemical Sciences, an NRCP Achievement Awardee in 2001, and an academician. His specializations are on natural products, NMR spectroscopy, and environmental chemistry. He is president of the Integrated Chemists of the Philippines, and he made headlines lately when he proposed coconut oil as treatment candidate for the novel coronavirus. I am talking about academician Fabian M. Dairit. Dr. Dairit, together with Dr. Mary Newport of Spring Hill Neonatology in Florida, USA, shared how the lauric acid and its derivatives in coconut oil have antiviral properties that may combat the virus. This recommendation was based on a review of several scientific studies which identified three mechanisms by which lauric acid and other coconut oil derivatives can inactivate viruses. Colleagues, we are happy to have with us academician Fabian M. Dairit. Sir?
Thank you. Thank you, Dr. Sumakisay. Salamat din sa invitation ni President Greg Del Pilar. First, maybe when I give my comments, I'd really like to follow up what Greg Del Pilar mentioned in his introductory remarks. This is a basic research symposium, and I agree with his observations that we really need to develop, herbal medicine to a more basic level. He mentioned this interaction with the Indian researchers on Ayurveda. What they are doing is they are combining their traditional practice and using science to support or to validate or to improve the practice of Ayurveda. So it is really a synergy between traditional knowledge, the use of traditional medicine, as well as basic science. So with that, and I think Secretary De La Peña also alluded to the same observation that we need basic research to promote herbal medicine. Now, listening to the talks this morning, I feel like, well, before the pandemic, so yung mga smorgasbord, yung mga buffet, all you can eat. Of course, you eat a lot, but really, people generally focus on certain favorite foods, and I guess it's similar approach, somewhat similar to herbal medicine, where there's really a smorgasbord of medicinal plants that you can work on. But in the end, you want to focus and deepen the study on a particular medicinal plant. Maybe to use another analogy, this is like, when biodiversity takes over an area, it's the biological succession. You start with, sort of preparing the groundwork, and then later on, more plants come in and they take over the area and go deeper into the land. So this is really what we should be doing. The talks that were given today were really very good examples of scoping the area, and we had some very interesting results, and I think many of them can be pursued further. So what I hope we will do is, in follow-up symposia, is to go deeper into what we have initially discovered. So, for example, well, of course, I happen to like marang as well, and I would like to know, more deeply how taking marang as a fruit would would benefit health. Not necessarily to treat it as a medicine, but as a, well, I guess the next step there would be a functional food. Same thing with studies on bioassay, all the selected Philippine medicinal plants. There's much that can be pursued going further into this. So I guess my general comments is first to congratulate NRCP for this smorgasbord of presentation of research on herbal medicine. But being a basic research symposium, it is hoped that this will go further, deepen the research on medicinal plants, and in the end, what we really want to do is to develop new knowledge on this and not just follow what other people may have done. In a way, that's what we're trying to do with coconut oil. In fact, the West doesn't like coconut oil, but I think we can prove that it's really healthy. So we should use basic science to deepen our knowledge regarding the resources that we have. So on that, I'd like to congratulate our four speakers and encourage them to go deeper into the research that they have started. And I think we're just scratching the surface. But in reality, we've been scratching the surface for a number of years already. So hopefully we can go deeper into the research that we're doing. So congratulations to everyone, and you're all still young. We're all young. I look forward to your continuing work and deepening the work that you're doing right now. So congratulations and keep up the good work. Yeah, thank you.
Dr. Diary, thank you very much. And I think not just our speakers, but those in the audience are taking your challenge. Go deeper into the new discoveries, more new knowledge, and think of the synergy between traditional knowledge and basic science. Salamat po. Another expert serving as a reactor today, for of course the four papers that were presented, is a member of Division of Chemical Sciences. Her specialization is on natural products, chemistry, and had NRCP-funded projects, the most recent of which is standardized anti-hyperuricemic extracts from selected Philippine plants. She has published a total of 25 scientific papers that garnered 190 citations. She has an H index of 7 and I-10 index of 6. She is currently teaching at the Institute of Chemistry, University of the Philippines, Diliman. To give her insights, we are pleased to have with us Dr. Christine Hernandez.
Thank you. Thank you for the introduction, Dr. Sumbesay. Thank you to the NRCP for the invitation. First, let me congratulate the presenters. All the four presentations were done very well. Okay, so I would like to know the sentiment of the okay, so we really need to dig deeper if we want to forward the natural products research in our country. That's why in my notes, my common question to the researchers were what would they do further? So in future directions of their projects. Can you hear me?
Yes. Yes.
Can you hear me? Okay. So I will not be repeating the sentiments of Dr. Dairit, but in my case, since we have, I think Dr. Secretary De La Peña mentioned that there are some students in the audience, high school students. So I have particular questions to our presenters. So for the first one, for Mr. Kirikinshana, did I say that correctly? Regarding the result of the in vivo plant, if you look at the in vivo portion, I would like to know what negative control you use, because it would seem that the blood glucose level is lower than the than your samples. So did you also look into the glycemic index of Marang? Because you know, it would seem that the blood glucose level are increasing, no? So also why look into glucosidase? Um, since you have several anti-diabetic drugs, why target glucosidase? So I guess we'll hear the response later on. And do you plan to also identify the compounds that are active in your plants? So for the second presenter, for Dr. Earl Yoda, thank you for the presentation. I'm particularly interested, what's the advantage of using renin inhibitors? So you mentioned the RAS system. So you also have ACE inhibitors there. So how do they compare? So for the appreciation of our younger audience as well, why was the HMG-CoA reductase inhibitor and the renin inhibition presented differently, right? So there were different concentrations tested. And you mentioned about saponins, so saponins that could be potentially active. But have you looked into saponins being promiscuous inhibitors? Right, so if you plan to identify, do bioassay guided purification of those plants, how will you eliminate the non-specificity, the potential non-specificity of the samples? And then for Dr. Katabay, thank you for that. I think we need really more studies on the possible herbal drug interactions. Not a lot of work is being done in that area. And I agree, okay, so we have a misconception that if it's natural, it's automatically safe. That's not the case, so thank you for mentioning that. So I would just like to know the error bars in your presentation. So I think I missed that. And I would like to know, of course, our audience as well, what are the future works that you plan to do to further explore the herbal drug interactions. Okay. And then finally, for Dr. Bulatao, so thank you for your presentation. I think that's a very interesting area of research. So not a lot is being done as well, looking into yung transdermal delivery. But would you know the nature of drugs that are ideal for such a delivery? And do you also plan to test for skin irritations, right? So that's a major concern if you want to look at such a delivery system. So that's it from my end. So thank you very much to all the presentations. So we're really happy that Natural Products, so it's actually now well funded by the DOST. A lot of work is being done in the area. So we hope to further develop and move forward in the commercial development of our herbal products. So thank you and good morning.
Thank you, Dr. Hernandez. And may we hear from our speakers? Maybe Dr. Kirikensha can start.
Good morning, everyone. I am Joseph Marie Kerekinsha from San Pedro College, Davao. And in response to the queries of our dear panel of reactors, first would be one of the reasons why alpha glucosidase inhibition model is chosen because this is one of the novel targets for target enzymes, should I say, in order to decrease blood glucose levels, since alpha glucosidase enzyme has a direct action on breaking down complex sugars into simpler forms of sugars like glucose that are readily absorbable in the bloodstream. Once this enzyme is inhibited, that phenomena of increasing blood glucose levels would also be decreased. And it is, again, like what I've said earlier, it is one of the novel inhibitory models for testing agents, hypoglycemic agents. Next question or query, it's all about the negative control group of test animals. The negative control group of test animals receive only the diluent or the vehicle of the extract samples right after the induction of hyperglycemia. All of the test groups animals had a significant increase of blood glucose levels, and one of my specific future directions or recommendations, if in case my research work would be used as a basis for other future basic research, is to explore more on other plant parts of this plant species that might have a bioactivity, and also an in-depth screening of plant compounds or constituents that are found on these different plant parts of this species. And also to the last query of our second reactor, I am also planning to have in-depth screening, specifically characterizing or elucidating the structure of that active constituent that might be present on the plant species. And that would be all. Thank you.
Thank you, Dr. Kirikinsha. Can we have Dr. Araliado, please?
Thank you for those questions. Well, regarding alpha amylase and alpha glucosidase, as what mentioned by Dr. Kirikensia, they are involved in the breaking of complex carbohydrates into smaller chain of glucose. So this process increases the amount of glucose absorbed into the circulation, which may lead to diabetes. So that is why inhibiting these enzymes decrease the available glucose in the system and help manage diabetes. So for another enzyme assay for diabetes, we also use DPP4 enzyme assay. This is multifunctional transmembrane glycoprotein involved in many physiological processes, including the enzymatic degradation of incretin. So what is incretin? These are incretin hormones such as glucagon-like peptide and gastric inhibitory polypeptide. These are important in the maintenance of normal glucose homeostasis. So inhibiting the enzyme DPP4 will result in an increased level of incretin, causing the inhibition of glucagon, elevating insulin secretion, and decreasing blood glucose levels. Now for HMG-CoA reductase, which is responsible for cholesterol. So inhibiting the enzyme HMG-CoA reductase inhibit the cholesterol biosynthesis. So as a consequence, it will decrease the level of cholesterol produced. Now regarding the specificity, or she mentioned about saponin, how are we going to address this? So in our future direction, we will purify our sample by the process of bioassay guided isolation. So from there, we will be able to determine whether this components affect the activity of our sample. And then, I don't know what else, what questions still I have not answered. So for future direction, in order also to have a better activity of these plant samples, we plan to have to combine the different extracts. Like for example, one extract is responsible for glucose, another extract is responsible for cholesterol, and so we will try to combine these extracts to see whether there is synergistic effect that we will contribute to address the disease. But that can be only possible after our purification, semi-purification, and purification test.
Thank you. Thank you, Dr. Arrollado. And let's hear from Dr. Katabay. Yes, ma'am.
Okay. Good morning to all, and thank you for those kind words, no, regarding our researches. And I agree that there is really a dearth of studies, no, regarding herb drug interaction. So the future direction of this research is to actually look at drug enzyme. So we're talking about enzyme inhibition now, and we're looking at enzyme induction. And the type of assay that we use is based on the production of luminescence. So this will be using the luciferin assay kit, gene assay kit, no? So we measure the activity of luciferase as an enzyme. So we're looking at that, but our main problem is that luminescence is very putative. So we're still trying to really optimize the system. And as an offshoot of this research, we actually have now a research on looking at biomarkers for this plant. So we're actually exploring the use of infrared spectroscopy in identifying whether we can have markers to look at when we do analysis of these herbal drugs. What we want to tie up is this. We have noticed that the result of our experiment varies within plants. Now, if we have plants from Cavite or plants from Iloilo or plants, same plant. But when we look at the IR, there's a big difference. So we are trying to make a conclusion whether the IR spectra that we get will be consistent with the activity as an enzyme inhibitor. So for example, no, so we see in our spectra that there's a biomarker that has a high concentration. Maybe this is actually the constituent that actually gives the inhibition effect. Or if we don't see this marker, no, that we are seeing in one type of herbal plant, no, depending on the location, and they have no inhibitory effect, then we can conclude that the constituent of different herbal drugs, kahit pareho silang same, like lagundi for example, based on where they come from, the inhibitory effect might be affected. So this is also a very interesting work to look at, no, because it will tie up why for certain herbal drug, for example, you see this inhibition, and then for the other drug of the same species but from different area, you don't see the effect. So this is actually we're looking at this because, like for example, bawang, this has been studied a lot, but if you look at the meta-analysis, they are saying that it works, and then another meta-analysis says that it doesn't work. But if you look at the species that they actually use or the location of this bawang, iba-iba siya. So I think there is a big factor on the activity of this plant. So in standardizing, like for example, lagundi, then we can actually prescribe what lagundi plant we use, no, where it comes from, or do we have like cultivate it in an area that we can control, no, all these factors, so that we can look at standard IR spectra, no, looking at all those constituent or markers. So I think this is a big area pa, and hopefully we may be able to do some of this in the future. Yan po. Thank you.
Interesting. Thank you, Dr. Katabay. Let's have Professor Bulataw, please.
And I would like to answer, I will respond to the questions of Dr. Hernandez. Her first question was, I think, what are the characteristics of, or what characteristics of the drug candidates that would be excellent for transdermal drug delivery systems? Well, the drug candidates that are excellent models for transdermal drug delivery should have a molecular weight that is less than 500 Daltons or grams per mole. They should have low melting point. Specifically, it should be lower than 200 degrees Celsius. The drug candidate must have a short half-life. It should be non-ionic, and it should have low bioavailability. So to relate it with my current study, statins are generally administered as oral dosage forms. In fact, this is the only FDA-approved route of administration for statins. However, there are some limitations associated with the oral administration of statins in general. And in terms of simvastatin, the bioavailability of simvastatin is very low. It's estimated to be only 5% after oral administration. This is due to an extensive metabolism in the gut and a subsequent metabolism in the liver. And so, simvastatin is also is also a hydrophobic substance. And so its characteristics make it an excellent candidate for transdermal patches. And for the second question, do we have plans for the skin irritation test? We did not actually include the results for the dermal irritation test, but we submitted our samples to the ITDI of the OST, and the samples were treated on the intact skin on the intact skin of rabbits, and the results showed that there was a very slight erythema. So this means that the samples are non-irritating, and this is good because transdermal patches will stay on the skin for prolonged periods of time. And what are the future plans for our study? I've actually listed down several items for future prospect for our study, because we can see a bigger picture here. We'd like to improve the screening procedures. We'd like to screen more factors, more variables that could affect the physicochemical characteristics of the formulation. And with that, we'd like to use screening procedures for optimization. So there are several available experimental designs for screening in optimization. And then in our study, we were limited by the quantity of, for example, the essential oils. So we could not implement an appropriate experimental design with a higher number of samples and to investigate multiple factors simultaneously. And then, we will also try again the permeation studies, for example, using the Franz diffusion cell, because we have failed when we first tested it. And then after we will find the right combination and right proportion of ingredients for the formulation, we would be able to investigate the mechanism of release of simvastatin from the transdermal patch, and one of the ingredients in our formulation is essential oil. And then we'd like to explore more on that as a permeation enhancer. And well, taking into consideration that permeation enhancers can have sometimes some in literature there are some reports saying that permeation enhancers can have deleterious effects on the mucosa. So we'd also like to embark on that. For example, the toxicokinetics of the samples. And also, lastly, we could design an experiment to perform other dosage forms like the recent trends nowadays, nanoparticles. So we could formulate like lipid nanoparticles using the essential oils since it has a permeation effect, and then that may be incorporated into the transdermal patch, and also to evaluate the pharmacokinetics of simvastatin in animal models to ensure its activity, also its safety. Thank you very much.
Okay. Thank you, Professor Bulatao. Yeah, from the answers of our four speakers, there seems to be so much to study and so much for DOST and NRCP to fund. And of course, we appreciate how basic research is now getting to be more appreciated by all sectors. So we now move on to more questions from our participants. And let me read the first question. So do we have the first question now? Yes.
We have a question for Dr. Kerekinsia. A hexane plant extract has a significant activity for amylase inhibition. How can a nonpolar extract be delivered to the body?
To answer the query, actually I used the alpha glucosidase model. Non-polar extract has a minimal activity on my in vitro testing, and usually non-polar extracts are subjected to rotary evaporation in order to remove the solvent, and before it would be subjected to bioassay purposes, first it must also undergo toxicity studies, like the acute oral toxicity studies, because that would be the basis for its dosing and at least a preliminary safety index before it would be subjected to a preclinical study or a biological assay.
Thank you, Francis. Do we have the second question?
Yes, we have a second question for Dr. Arrollado. To Dr. Arrollado, DPPH is simply a general test for antioxidant activity. How is it related to hypoglycemic activity?
DPP4, no, this is a multifunctional trimembrane glycoprotein involved in many physiological processes, including the enzymatic degradation of incretin hormones. So what are incretin hormones? The example of these are glucagon-like peptide and gastric inhibitory polypeptide. So these incretin hormones play an important part in the maintenance of normal glucose homeostasis. Inhibiting the enzyme DPP4 will result in an increased level of incretin, causing the inhibition of glucagon, elevating insulin secretion, and decreasing blood glucose levels.
For our third question, it's for Dr. Katabay. The inhibition of CYP3A4, or the third CYP P450 studied by garlic, is not in a dose-dependent manner. What may be the reasons for this result?
Okay. Hello. Can
Yes.
you hear me? For the CYP3A4 enzyme, the concentration actually becomes a limiting step for us, no? Because what we wanted to do is to have the enzyme purified
So the activity of the probe that we use, which is your BQ, is not that specific. So unlike the 7MR, no, and the other BFC, the probe that we use, which is BQ, okay, or your benzyl oxyquinoline, uh, does not react on a dose-dependent manner. So we screened actually different concentration of garlic, and we look at the highest concentration that we can prepare and look at uh, the the inhibition effect for the enzyme. And we would like to have a purified enzyme, but that's not possible at this time, no? So with the 3A4 assay, our suggestion actually is to look for another probe, because the effect is not actually consistent. So you're right, no, with the dose of the garlic. So we screened many concentration, and based on our study, so that's the concentration that actually gives the result. So we tried 3 concentrations actually, but every time we don't get the correct or dose dependent reaction, because our conclusion is probably our probe should be changed. Okay, so there are a lot of probes that we can use, no, for CYP3A4 enzyme. The problem with CYP3A4 enzyme is that we cannot really have a conclusive mechanism for it. And yun nga ang nakaka sa aming research, because CYP3A4 actually metabolizes 50% of most drugs. So talagang siya ang nagme-metabolize, but it is less specific. So hindi pa tayo nakakahanap talaga ng very, very enzyme-specific probe for CYP3A4, unlike yung dalawang nauna.
Okay, thank you. Yes, Francis, you have some more questions?
We have another question for Dr. Arrollado. What is the source of the alpha-glucosidase used? Was the possible interference of the polyphenols with the spectrophotometric assay addressed during the conduct of the alpha-glucosidase study?
I think it's the color. No, it's the color that affect. It's one factor that interfere with the spectrophotometric assay. It is the color of the alpha glucosidase.
This is a general question. What courses can you suggest for students who want to have a career in pharmacognosy?
Okay. So we have interested young future scientists in our audience. Yes, any advice?
May I have the floor, ma'am?
Yes.
Oh, okay. Unfortunately, no, when you look at the pharmacy curriculum now, pharmacognosy is now limited, no? It's actually one subject now that is combined with plant chemistry. During my time, that was a long time ago, so we have pharmacognosy, a lot of pharmacognosy. We have actually 2 subjects. Okay, but the direction is that if you want to have a career in pharmacognosy, you should start with studying botany. Meron din naman tayong botany, taxonomy, and then plant chemistry and all these things, no? So pharmacy is still, I think, a good course for students who want to have a career in pharmacognosy, and then they can do future study like an MS. Meron ding specialized courses in pharmacognosy or natural products for that matter, no? So hindi lang talaga specific for pharmacognosy, but you can go into natural product chemistry, for example. Even BS chemistry has that, no? So I think there are a lot of courses, especially those courses that are chemistry based. and then you go up the ladder and you apply it, your knowledge in chemistry with natural products, and then pharmacognosy, taxonomy, and all of this. So, but for me, go take BS pharmacy. That's my advice. All
Well,
of us are
sinabi si Ma'am
pharmacists, ma'am. Ma'am, all of us, by the way, are pharmacists. The four of us.
Yes, yes, yes. In fact, I'd like to say congratulations to the Division of Pharmaceutical Sciences. Lahat po kayo, it's your day. So,
Yes.
salamat po. Some other advice from our other speakers? Yes, Dr. Arellano, you'd like to say something?
First, no, when you say pharmacognosy, it's about plants. So first, for me, your interest in the surroundings, in your environment, is one way that will motivate you in choosing your course. So your exposure in the fields, in the farm, in the situation where you are, this will also help you to appreciate the plants that you will be studying later on. So pharmacy for me is the best course in order to pursue pharmacognosy, because pharmacognosy is already a specialization in the field of
Dr. Sumagay,
pharmacy. So if the person has interest on plants, then this is the best course for her or for him. So the interest must be very important in choosing the kind of career you are going to undergo. Thank you.
Thank you, Dr. Arellano. In the interest of time, we will have one last question. So, Francis, please help me read the question.
this is for Dr. Katabay. Dr. Katabay, you mentioned that there are differences in the biomarkers of the same plant species collected from different sites, resulting to differences in bioactivities. How about if we collect the plant from the specific site, then plant it in a controlled environment? Do you think that the biomarkers for the plant will still be the same?
Okay, that's what we are actually suggesting, no? Because looking at plant to plant, no, in different areas, and you look at the profile, no, using yung mga probe for biomarkers, like for example IR, makikita mo that they actually give you different profiles every time. So the best way, I think, is to have a place where you plant all these herbal drugs that are shown to have pharmacologic effect. So yung mga plants that are already established that gives you pharmacologic effect, meaning ito yung mga herbal drugs that actually are elevated now to drugs like lagundi, sambong, no, so marami pa, no, Acapulco, etc. They are now a part of mainstream medication. So drugs na sila. However, yung mga sources natin nakita namin, no? So this is by chance that we saw na iba-iba ang profile nila. Kasi iba-iba rin ang soil, iba-iba elevation, iba-iba ang weather. They have different profile. Okay? So, gusto naming i-equate, this is what we're doing right now. We wanted to equate this profile with the activity. So, nag-iiba ba ang activity pag different ang profile? So, right now, that's our inference namin, ini-infer namin that yes, because based on our initial studies, no, yung mga ibang plants wala activity. Tapos kumuha kami ng ibang sample, like we use a standard, may binili kami rin na standard from Urbanex, for example, kay Sir Philip, and then we use that. So we see different profiles. So we wonder, magkakaiba-iba kaya yan? So if it's possible to have a certain plantation, no? So let's look at the plant that has a good, no, profile for interaction, enzyme interaction, or for inhibition and induction, and then look at the IR profile, and then yun ay cultivate natin ang plant so that we will know that in the future, yung drug na ginawa natin for herbal medicine, wala siyang herb-drug interaction. So this is actually a good field na wala pa talagang gumagawa, no? So I hope we can really venture into this. So thank you for that question.
So thank you very much. Thank you to our speakers, and thank you, Francis, for assisting me in this portion. We now close the Q&A portion of our symposium this morning. And may I invite our participants to give our speakers and reactors a virtual round of applause. Okay. NRCP congratulates the Division of Pharmaceutical Sciences for the 4 basic researches conducted and presented today. We take note of the recommended topics for further studies, as well as the possible utilization of the research results. May I remind the participants to please accomplish the survey form. Please click the link that is provided in the chat box. And upon exit from Zoom, you may start answering the survey form. We will send you your certificates of participation once we receive the filled out survey form. At this point, may I call the NRCP Vice President and the Chair of Division 13, the Division of Veterinary Medicine, for his closing message. Dr. Claro N. Mingala.
Thank you very much, Dr. Ladies and gentlemen, my colleagues in the National Research Council of the Philippines and in the scientific community, our beloved guests and speakers, thank you very much for joining us in this 4th Basic Research Symposium. Thank you for gracing this event and making this as a success and unforgettable. The knowledge you shared to us has no monetary equivalent, and we will always grateful for this valuable information you imparted. Truly, basic research is the foundation of knowledge that many of our scientists and researchers is using to come up with a worthwhile product that our country benefits from. Our young researchers and policymakers will be well-informed and inspired at the same time. It's great work of science. We are now closing this event, the 4th Basic Research Symposium, amid the COVID pandemic. Will leave us inspiration to use research for the common good of all. Thank you very much. Maraming salamat po sa lahat at mabuhay tayong lahat.
Thank you, Dr. Mingala. Salamat po. To all our participants, researchers, scientists, artists, and engineers, NRCP sincerely thanks your attendance and participation in today's 4th Annual Basic Research Symposium. Let us deepen the portals of basic research and let us continue our advocacy for a heightened appreciation for basic research by all sectors, that is, by the academics, the policymakers, the industry, the National Budget Office, as well as the young and next generation basic researchers. We are all in this together because we know that basic research starts it all. Ladies and gentlemen, the 4th Annual Basic Research Symposium has just ended. I am Dr. Marieta Banyas Sumagaysay, the Executive Director of NRCP, the Symposium Moderator. Godspeed to all.